Today we're going to show you how to find the number of solutions between two lines.
There are three types of solutions here. So if two lines are parallel, they will never ever meet each other. So that means they're gonna have no solutions. So in an equation form, we're gonna have y equals m1x plus c1, y equals m2x plus c2. So to have no solutions, gradients should be the same because they're parallel. So m1 equals m2, but the y-intercept should not be the same. So c1 is not equal to c2. So if you see two equations with same gradients and different y-intercepts, they're not gonna have any solutions. Second is when they have a unique solution. So to have unique solutions, there's only one condition. Gradients should not be the same, so that they intersect at one point. So m1 is not equal to m2. Next one is when they have infinitely many solutions. So there's one line here and there's another one which is exactly the same as the one I drew just then. So if they have same gradients, same y-intercept, they will be the same equation. So every single point on the line will be the solutions. So if m1 is same as m2 and c1 is same as c2, they will have infinitely many solutions. So let's have a go with the examples here. Example 1 is y equals 2x plus 1, y equals 2x plus 3. Let's see how many solutions they have. The gradient of the first one is 2, gradient of the second one is 2. Y-intercept of the first equation is 1 and y-intercept of second equation is 3. They have same equation but different y-intercepts, so they will not have any solutions. Example 2 is 4x plus y equals 3, 2y plus x is 4. The equations are not in y equals mx plus c form, so we cannot find m and c values straight away. So let's rearrange the equations so that we can find m and c. So the first equation, we have 4x plus y is 3. Let's move 4x to the right. It will be y equals negative 4x plus 3. Second equation, we have 2y plus x is 4. Let's transfer x to the right. It will be 2y equals negative x plus 4. Divide every single term by 2 to get rid of 2 in front of y. So it will be y equals negative half x plus 2. So m1 will be negative 4, c1 will be 3, m2 will be negative half, and c2 will be 2. As they've got different gradients, so m1 is not same as m2, that will have a unique solution. The last example here is y equals negative 2x plus 5 and 2y equals negative 4x plus 10. If you divide every single term of the second equation by 2, it will become y equals negative 2x plus 5, which is same as the first equations. As they are the same equations, they will have infinitely many solutions.
Thanks for watching today's video. Click the link below to check out our awesome website. Check out our channel for more study tips and click here to watch our last video. Don't forget to like and subscribe, and we'll see you in the next video.